Hi, I'm Dr. Courtney with the Quantitative Reasoning Center, and we've been talking about the 5 frequently fatal freshman fantasies. The first one was the fantasy of the miracle finish. The second one was the fantasy of the soft-hearted professor. And the third one, the one we're talking about today, is the fantasy that weak areas won't be tested. And this is the idea that if you're good at some of the material in a chapter or in a section or in a unit that's going to be covered on a GR, that the test or the graded review is going to focus mostly on the things that you're good at. And the things that you really haven't pressed into or studied as much or you really pushed through until you could complete every problem, the weak areas like that are just, you're going to get lucky, and those things aren't going to be important on the graded review. This is the fantasy that weak areas won't be tested. All right, so today we're having a look at 15.3, number 41, and keep in mind that I've changed the numbers just a little bit. All right, so let's go ahead and make our plan. And what we need to do is we need to reverse the order of integration. In other words, as it's given to you, it's expecting you to integrate over the variable x first as the inside integral, and then it's expecting you to integrate over y as the outside integral. So let's make our plan and let's sketch the region. And sketching a region of integration is always a good idea. Even if you're not told to sketch it explicitly, it always helps you keep straight and think through how to really arrange your limits of integration and prevents lots of mistakes and gives you a sanity kind of double check. So you want to sketch the region, and let's also write the integral explicitly as given. And what I mean here is we want to add x and y to the limits out here and not just infer them from the order of the differentials on the right side. And now we can write integral with reverse limits. Of course, we're writing it with reverse limits, but we're covering exactly the same region in the xy plane. All right, so let's go ahead and think about what we're given. So, if we had x equals negative 16 minus y squared, well, this is a semicircle where x, of course, is always negative because we have a negative sign in front of the radical, and it's a semicircle radius 4 centered at the origin. The upper limit of integration in x, because of course when you're integrating in the xy plane, you're integrating from curve to curve, so the right hand side is the upper limit of integration in x, and this is the right hand semicircle. So the two semicircles form a complete circle, and the complete circle has a radius of 4, and it's centered at the origin. All right, well, let's think about our limits of integration in y. Our limits of integration in y go from 0 to 4. So basically that's telling us that we're not ever integrating below the x-axis because y is starting at 0 and ending at 4. So we end up with the portion of the semicircle in quadrants 1 and quadrants 4. So let's rewrite the integral explicitly as it's given. So this would be x equals negative square root of 16 minus y squared, and x is equal to positive square root of 16 minus y squared. The integrand is f of xy, and it's first over x and then over y. And the outside limits of integration are y equals 0 to y equals 4. And just reminding ourselves of the variables of integration over here at the lower and upper limits just helps us keep it all straight. We're working on two-dimensional integrals now. In the next section or two, we're going to be working on three-dimensional integrals. There's 3 variables of integration. it just helps keep it straight from a bookkeeping point of view. All right, so now to reverse the limits of integration, the inside is going to be y equals something and x equals something. The integrand doesn't change. And then you reverse the variables of integration, the inside integral now being over y, and the outside integral being over x. This, of course, being the inside integral, and then this being the outside integral. All right, well, what's y min, or the lower limit of integration in y? Well, that's y equals 0, because that's just the x-axis. And then what's the upper limit of integration? Well, let's go ahead and draw this one in first. Well, this is y is equal to plus the square root of 16, I'm sorry, messed that up, plus the square root of, oh yes it is, 16 minus x squared, because you're talking about the upper semicircle, and it would be x squared plus y squared equals 16 would be the whole semicircle. And then a couple steps of algebra to solve for y and to make it the upper part of the semicircle by taking the positive rather than the negative square root. All right. What's the lower limit of integration in x? Well, that's negative 1, 2, 3, 4. And the upper limit of integration in x is 1, 2, 3, 4. And so this is our rewritten integral having reversed the order of integration.